even have it.
I'm happy to come and have you check me out and see if you can find it.
Sign us up.
It all sounds good to me.
Yeah, but you're right. Everybody has a different adrenaline response. So Phil has incredible stress, or even things that other people would think would be fun. His blood sugar goes through the roof. And
Okay.
everybody has a different experience, and they learn to figure out how to dose for that, and adjust their settings based on our algorithm.
Yeah, but I mean, then again, the algorithm is changing, right? I mean, the beta cell is probably the smartest cell in our body. I'm so impressed with what the beta cell can do. It's mind-boggling.
Really, the key
If
to
you know that a single beta cell can make 1 million copies of insulin in a minute, one beta cell, 1 million copies in a minute. I have to repeat it myself because I cannot believe it. And if you then imagine that it is not just making it, it's only releasing it, and only then when you need it, right? So, wow.
Yeah, the key to loop is that it's essentially looking at your blood sugar every 5 minutes and predicting where you're going based on that trend, and then raising and lowering how much insulin it's delivering.
Yeah.
So it's not really so much looking specifically at...
No, but because your beta cells are even innervated through the brain.
Oh, the beta cells are a lot more accurate at it.
No, I know. I mean, they can even, with your mood changing, it automatically sends signals to the eyelid, hey, back off, or maybe boost a little, because something is happening. I mean, it's just spectacular. So it's a great motivation to. I think that about 80% of you still have beta cells, and they're hibernating. And if we can get them back to work, not through the brain.
Yeah, I need mine back to work. I'm a type 1B, so I don't have any of the antibodies. I don't have the autoimmune. I just don't make insulin.
I meant to unmute me.
I just got muted. I think Joanne didn't like my.
No, I think it was me. I went to mute.
That was me. That was YouTube is live, and it was on me. I thought it was cats. I'm sorry. No, you're all good now. It was me. Sorry.
So most long-term type 1 diabetics still have some active beta cells?
Well, they're not always active.
Okay.
But I was involved in a study in what they call the English Riviera. I think that's a bit of an overstatement, but at Exeter, and they found in 80% of the patients still C-peptide in the urine, and many of those didn't even know they made it, right? So, but it means there is something out there that is hiding, and that is, for me, increases the sense of urgency to protect those. And I think I pretty much know how to get them back in action, but I don't want to, because I think they're hiding from inflammation and other stuff. So, you need to really reset the system, and then I'm happy to make them work again. But it's really amazing to see that there is this such thing as beta cell function 50 years after diagnosis.
Wow.
For what I understand, a fairly high portion of Jocelyn medalist studies, medalist participants have been found to have functioning beta cells, the 50+ year group.
Yeah, but that is a very selective group, and I actually don't like that group, because I think that every person with diabetes deserves a medal, whether or not you get complications. And the gold medalists are the ones that get a medal because they have been without complications for 50 years. So that's a selection for those that are lucky enough to preserve their beta cells. But so there is a selection. But you're right, that group is the ultimate proof that you can. I saw an autopsy of a woman who died 62 years after diagnosis, and half her pancreas was stuffed with insulin. It was just bizarre. But that's an exception. But still, you only need 10% to be cured. So there is really something to be working on. So Joanne, how is it working? Are we waiting for people to log in, or what?
We are, and Cass is putting it out onto the Facebook group. But we're going to start because a lot of people come in later, and also they watch later. And you're the outlier. Yeah, you're not telling them which device you're going to be selling them.
No. Well, I tell them to use their own device, I think. Yeah.
Exactly. So we have a few people coming in, and I think there are a couple of people on YouTube. So I'm going to start if everyone's ready. We can all just kind of blank out our screens, except Bart, you can stay there. And everybody ready? Okay. Hello, everybody. Welcome to Loop and Learn T1D speaker series. And today is an interesting and unusual event for us. We're not going to be talking about companies that manufacture devices that we might want to use. It's like, how do we get cured from diabetes? And I think that's really our goal. So we get to hear from Bart Roep, PhD and director of the Wanek Family Project for Type 1 Diabetes at the City of Hope. There's a tremendous amount of work and funding going into the City of Hope, and we get to hear a lot about this. So stay tuned and sit down to get ready to take notes if you'd like. And let's go through our normal disclaimer that the Loop app is a do-it-yourself closed loop algorithm. While it may seem obvious, please consult your healthcare professionals regarding your diabetes management. And remember that this project is highly experimental and it's not FDA approved for therapy. Therefore, you take full responsibility for building and running this system, and you do so at your own risk. And a little plug for loopandlearn.org, our website that just was started at the end of November. It is looking so terribly, terribly professional, and there's so much information on there on how to do stuff and how to live with Loop, on how to start, announcements when there's updates on Apple and Xcode and everything else you need, hot tips and topics on how to eat and manage with Loop. There's a newsletter that goes out about the events and just pretty much every topic that you might need to know about. And if you don't see it there, ask us. And I put the names of the people that are involved. There are so many people and there's a lot of work going on. But Marion is the super duper editor who has made it look so very good, with Ivana, Carol, Barb, Mark, Kenny, Priscilla, Glenn, and many, many, many more volunteers. So bookmark that page, take a look at it, sign up for the newsletter so you'll be updated when there's something important to know. I'm going to now just tell you a little bit about Bart Roep and why he's speaking to us today. He is, I hope I say this correctly, the Soon-Shiong Shapiro Distinguished Chair in Diabetes within the Diabetes and Metabolism Research Institute at the City of Hope in Duarte, California. He serves as project director for the Wanek Family Project for Type 1 Diabetes at City of Hope, an ambitious initiative, well-funded, I have to add, committed to developing a cure for type 1 diabetes. Yeah, you heard that correctly, a cure for type 1 diabetes. Dr. Roep is internationally recognized authority and key opinion leader on multiple aspects of type 1 diabetes, with a particular interest in understanding the cause of the disease and translating that knowledge into immune intervention strategies, including gene therapy, stem cell therapy, and bone marrow transplantation, with the ultimate goal, once again, hear it, to cure type 1 diabetes. His mission is to cure this disease. His quest for over 25 years has been honored with multiple scientific and medical awards, including the most prestigious national and European awards in diabetes, such as the Minkowski Prize for outstanding contributions to the advancement of knowledge in the field of diabetes mellitus. I could tell you more, but I don't want to take time from him. He, just so you have his background, he received his medical and doctorate degrees at Leiden University in the Netherlands and his Master of Science degree at the University of Amsterdam. And a quote from Dr. Roep is, "I am very monogamous. I only work on type 1 diabetes." We all heard that this morning. We all loved it. Dr. Roep, thank you. Thank you so much. Share with us whatever you want to tell us. We want to learn from you.
Well, Thank you, Joanne. You can hear me. I will share my screen in a minute, but I thank you for the kind introduction. But I also have a disclaimer. I want to put this group out of business. That is my ultimate goal, right? Because the best closed loop is inside of you, and I hope that I can convince you that there is something to be rescued there, and that is my mission. Well, I will start with a slide deck. It's only 24 slides, but it will show you a little bit of the context, and I hope that we have time to discuss and answer questions, because whenever I talk, I raise a lot of questions because I really am opening a can of worms. So I'm working since a couple of years at the City of Hope in Duarte, now also in Orange County, by the way. And this is a very interesting place because it's the birthplace of synthetic insulin. It is the place where Arthur Riggs in 1980 for the first time was synthesizing insulin. So we no longer had to take it from leftovers from the butcher. Imagine, porcine insulin, bovine insulin. From now on, ever then, we could make it synthetically. So that it's also the birthplace of HbA1c and the place where we got to learn how insulin works, Rachmi Levine, and the place where the insulin receptor was first discovered. So it's an amazing place and nobody knows it. But another interesting part of it is that across, this is the Diabetes Institute on the right, and across the street, across the lawn, I should say, there is another institute, which is what City of Hope is most famous for, and that's the Cancer Center. I'm trying to tell you how I'm learning from cancer. I sometimes jokingly say, I want to learn from the oncologist what not to do in type 1 diabetes, because it happens to be the complete opposite. And this is a kind of a cliffhanger and a teaser to be sure that you stick around before we go to the Critics' Choice Movie Awards in an hour or so. But this is City of Hope, and I'm trying to really make a dent into finding cures for type 1 diabetes. Now, the first slide is kind of the blueprint of how we think that diabetes starts, because I contend that you need to know the cause of the disease to really be able to cure it. That sounds like kicking in an open door, but it's really very important. And here in the bottom in green, you see an islet of Langerhans, just the beta cells in there. Sometimes the beta cells die, and then we have these professional vacuum cleaners called dendritic cells or DECs, and then they get rid of the cell debris and nothing happens. But in some cases, some T cells escape immune education that can recognize those beta cell products. Now, T cells are immune cells, and they can actually tell other cells like B cells to make antibodies, which is the smoke of the fire. The real fire is that they can also activate what we call killer cells. And those killer cells can destroy the beta cell. And then this vicious loop is continuing, and you will lose all your beta cells in time. Now, the good news is that everybody, and I mean everybody, also people with type 1 diabetes, have regulatory T cells or Tregs. And those Tregs are able to suppress this whole cascade. And my flash forward will be, if we can activate this arm of your immune system, you can basically stop disease progression and preserve all the beta cells that you have. And here's another little secret. About 80% of people with type 1 diabetes still have beta cells. They may be hibernating, you may not even know it, but you only need 10% to be cured from diabetes. And all the textbooks are wrong. All the medical textbooks that I was reading when I was a medical student are wrong. They say you're diagnosed when 90% of the beta cells is destroyed. And that's not true. Not maybe even 50%. And you only need 10%, remember? So there is a growing sense of urgency to protect those cells and be able to get them back in action, so you can make your own insulin and don't need any artificial loop to do it, no pun intended. Now, when I talk about curing diabetes, certainly for my favorite stakeholders, the patients and their relatives and their friends, I always have to have this disclaimer, because this is just an overview of all the clinical trials that happened in the last decade. And as you know, there is no cure there yet, not obviously. So why do I even talk about this? Well, there will be a cure, and we have already cured people with type 1 diabetes. But let me also dwell upon this a little bit. What do we call a cure? Because I'm an immunologist, right? I study immune responses that destroy the beta cell. So for me, a cure is finding something that stops that process, so you will not destroy those beta cells anymore. But for a nephrologist, it means preventing kidney complications. For an eye doctor, prevent blindness. For you as patients, I know that many of you are most concerned about those complications, and in particular the hypoglycemia being too low, and particularly at night. If I can prevent that to some, that may be a cure. So there's all kinds of definitions, but please rest assured, I will not rest, and this is a solemn promise, I will not rest until you may even be able to stop injecting insulin. That is the home run or the slam dunk if you live close to LeBron James, as I happen to do here in LA. All right, so these were things that didn't really work. And so there is a bit of a wake-up call because we now only recently, and this is literally work of the last 1, 2, 3, 4 years, that's really fastly growing new insight. We know, as you already did as patients, that diabetes is diverse, and so are patients. No patient is alike. So when you read Countdown or you read books about diabetes, you always wonder, that isn't me. And you were right. I should have listened sooner. Every patient is different. So that should prepare us that there will not be a magic bullet that cures everybody. Okay? So that's number one. And number two, all these drugs on this slide, they are suppressing the immune system. I honestly believe that people with diabetes have the best immune system in the world. The gene variants that increase your risk are the winners of the Middle Ages. They give you the immune response that cancer patients are craving. And I know because I'm working with oncologists. They are the immune genes that you want to have to be protected from COVID vaccination, but also COVID infection. So these are the genes of the survivors of the Middle Ages. And your immune system is fantastic. It may be a little bit too good because it may even respond to unhappy tissue in the assumption that it could be infected or looks like cancer, even though it really wasn't. And I'll get back to that in a minute. So don't suppress the immune system, you better engage it. And that's what I'm working on. The other thing is to know is type 1 diabetes is not a systemic disease. It is only affecting your islets of Langerhans, which is only 1% of your pancreas, and only the beta cells in the islets, not the other cells. So it's extremely local and it's extremely focal. Some islets may be inflamed, but the islets next to it will not. And I will show you proof of all of these blunt claims in a minute, don't worry. Then the other surprise is that unlike what mouse models made us believe, diabetes in humans has a very rare inflammation, very moderate and in only a few islets. So don't use big hammers, do be more sophisticated. Our body deserves that. Finally, and this is not trivial, we just discovered that diabetes type 1 is a beta cell disease as much as it is an immune disease. So immunotherapy alone will not be enough. We must make islets happy again, and then we have the perfect storm to cure type 1 diabetes. So this is the wake-up call, and this is why I think things have failed in the past. So we have to do things completely differently. We have to have a next generation of light to really cure type 1 diabetes. And that's where the Wanek family stepped in. The Wanek family is a wonderful group of people in Wisconsin. They are the founders of Ashley Furniture. They have type 1 diabetes in the family, and they decided to make an investment with a huge gift to try to find strategies to cure type 1 diabetes as a philanthropic gift. So what is the Wanek Family Project? Well, as I said, it's a joint venture with the Wanek family as well as other corporate partners. And we want to cure type 1 diabetes. That is a high bar, but that is the only thing we care for. And we do this by developing novel strategies that are targeting the cause of the disease, not the symptoms. The closed loop is great, but it's not curing you. It is dealing with the symptoms. It's palliative care, so it's not good enough. We started off with $54 million, which is not bad, but we are very ambitious, and we have been able to increase the value by fundraising and additional philanthropy to over $130 million. So we really can make a dent into this, and I'm really proud of working with this group of people at City of Hope to make this all happen. I also want to say what we are not doing, because the Wanek family was very clear on what they want and what they might care less for. We don't care about mice. So all my studies are with real people. I don't call you patients, I call you people, people with type 1 diabetes. That's what we do. We don't want to cure type 2 diabetes. I think exercise and diet can get you a long way. I don't really want to work on that. I want to work on curing type 1 diabetes. Either transplantation is not what the family nor I care for. It's a great proof of concept that you can cure people, but it's at the end of the fight. And I want to stop that fight much sooner, so you don't need islets. And you don't need to suppress your immune system to prevent rejection. And it's not just clinical trials. We also want to really understand more about the disease. And in particular, we want to understand why every patient is different, because then, like in cancer, we can develop a personalized medicine. So we only treat you for the disease that you have and not one of your soulmates with type 1 diabetes. So that is what we need to do. So I mentioned the wake-up call, the disease differs, and so do patients. You knew this, I just learned it. It's not a systemic disease, it's moderate. It's a beta cell disease, so we must also make beta cells happy. Immune suppression is probably a bad idea. And we have to bear in mind that, you know, what I bluntly call palliative care, treating the symptoms, isn't so bad. Certainly not if you have a good closed loop, but it's not good enough. It's not a cure. But once we do it, it better be safe and it better be tolerable for it to compete with a closed loop. So those are the things to keep in mind, and I will show you how we're doing this. Now here is my first proof on the fact that the inflammation is so minute. Here you see an islet of a 12-year-old boy who unfortunately died about 10 months after diagnosis. And it's a horrible reminder that this is a deadly disease, and just treating the symptoms is not good enough. So the parents of this boy were wonderful in their distress to share the pancreas. And what we discovered is what I've been claiming for a while now, that there is still plenty of insulin, which is the green that you see in this islet. It's unbelievable. This boy died of insulin shortage, yet the islets were stuffed with it. Why weren't they producing it? Well, that's because some of those red cells, I hope you can see them here, are the inflammatory cells, but it's only a few. And here we have another stain of those inflammatory cells. It's only a few. So when we want to stop those cells, we should be very, very accurate and precise to only destroy these and not the other ones that we need to fight COVID and cancer, right? So it's a very subtle disease. That's a new insight. Also, and here is another segment of a pancreas with different lobules of the pancreas, you see segments of the pancreas that are completely normal, look completely normal at least, because they still have insulin, whereas other parts of the pancreas don't have insulin, but they still have the alpha cells in the islets that are producing glucagon. So you can see that even within one particular patient in one particular pancreas, the neighboring islets can look happy, and they are the ones that I want to preserve. Now, type 1 diabetes doesn't come in one flavor, in one color. I'm originally from the Netherlands, which explains the Schwarzenegger accent. And these are tulip fields in April. If you come to my country, the Kingdom of the Netherlands, every line is a different type 1 diabetes patient. So we have many different flavors, and we need to understand how they differ and how to treat those differences. That is our task. And it matters, even age matters. And I don't go into details, but if you stain the lesion, the disease area in the pancreas in a child below the age of 7 at diagnosis and compare it to a child beyond the age of 13, it already looks different. So even the inflammation is different. And age is one of the stratifiers. And that's important because when you look at therapies, and here's a long list of trials that we did, and all the time the conclusion is they don't really work. But that's wrong. When you really look into the raw data that are always accessible online, you can always see a group of patients, and here you see ages from 0 to 50, just for the sake of it. And some drugs only work in adolescents and not in adults. And some actually make things worse in non-white patients, so ethnicity is important. But there is always a subgroup of people where it works. So we should go back to those studies and see why it works, when it works, and why it fails, when it fails, and not throw away the child with the bathwater. I'm still struggling with that English expression, but I guess you understand what I mean. So age matters. And here's an interesting one. This is abatacept, one drug. And here's another one, rituximab, another drug. And rituximab only showed some efficacy in adolescents, but not in children and adults. And abatacept had the opposite. So we could already, just by age, be able to select one drug or the other and just see how things are going. But mind you, these are tough drugs with side effects. But it shows that we are making slow steps towards precision medicine. And here's a bigger step from my own work, where we try to make, let's say barcodes, immune barcodes. So we were reading the blood of the patients when they were on the waiting list to be treated. And when they have a favorable profile, I make the barcode green, then you can see that with islet transplantation, almost all of these patients are cured. And with autologous bone marrow transplantation, all these patients are cured. All these patients are cured, human beings. Whereas if you have an unfavorable immune signature, you can see that either it doesn't work at all, like with islet transplantation, but we can predict it now on the waiting list, or a third of the patients had no benefit and all the others with that signature were relapsing. So we can already, before therapy, try to understand where the disease differs and decide what to offer, and also importantly, what not to offer. But bone marrow transplantation works. And mind you, this is autologous bone marrow transplantation. You are your own donor. And at City of Hope, we have done 15,000 of them in cancer. So yes, there are risks, but it cures cancer, right? So maybe for some patients, this could be the magic bullet, even though there are risks involved. So what are we going to do in the Wanek Family Project with all this new insight? Well, the good thing is I don't have to write grants because the money is on my account, on the account of City of Hope. So if patients differ and if the disease differs, we have to find personalized medicine. And since I don't want to suppress the whole body, I want to have precision medicine in the sense that it should only affect the problem being inflammation in the islets and not your response to COVID or against cancer. Okay? So that's important. We also know that the lesion is relatively moderate. So I try to not treat the whole body, but only treat the pancreas and the draining lymph nodes of the pancreas to keep it local, keep it focal. Then, since I now understand that diabetes is not just an immune issue, it's actually the real problem is in the islets, we also must make islets happy again. So immunotherapy alone is not enough if the islets provoke the immune system. So we need to treat the islets. And then I honestly believe that the immune system is not interested in happy tissue. It has been taught to respond to distressed tissue. And the islets of Langerhans are the hardest working cells in our body. One beta cell can make 1 million copies of insulin every minute. Think about that, one beta cell. No wonder it can get stressed, right? And that is what your fantastic immune system is able to distinguish from an unhappy islet. So I actually think the immune system is responding with good intentions. Now, if that's the case, then don't suppress the immune system, but negotiate with it. Don't bombard it into submission, but teach it how to do it right. That is my strategy to cure type 1 diabetes. And since insulin isn't so bad, I also want it to be safe and tolerable to the patient, which means that biologicals are as good as it gets. I don't want to use chemotherapy or horrible stuff like that. Then I prefer insulin. All right. Now let's think a little bit about the immune system, because the immune system is particularly sophisticated. It's a very accurate balance between protecting us from cancer and infection with a strong immune response, but it should not be too strong, because then it could cause inflammatory diseases like arthritis, MS, or type 1 diabetes, or colitis, psoriasis. So then it is a very narrow balance that you need to do. And if you suppress the immune system, which we can basically stop the disease in every patient, but the chance that you die is too great. But we can do it. We just need to do it in a better way. If you activate the immune system in cancer to unleash an immune response against the cancer, some of these patients actually get type 1 diabetes. So you have to do it just right to just deal with the problem, but not causing side effects. Now there, working at City of Hope, for me as an immunologist and diabetologist, turned out to be like almost being in the candy store in a way, because I could just learn from cancer how not to do it in type 1 diabetes. Now here are 4 world famous cancer therapies. Cancer therapy has changed radically in the last decade alone. It used to be surgery, irradiation, chemotherapy, and now it is in many cases immunotherapy. That's what I want to do in type 1 diabetes. And some of those immunotherapies are what we call CAR T cells, so with an engineered receptor that we put in the soldiers of the immune system. And I want to do the same, but the complete opposite in diabetes. Not engineer the soldiers, but the negotiators, the Tregs. So we do the complete opposite. In cancer, we have very fancy antibodies against the tumors, and we can put a backpack there with a toxin, so when the antibodies get to the cancer, they will destroy it. That I want to do in type 1 diabetes, but the complete opposite. I want to have antibodies that go to the inflamed islets, but then not deliver a toxin, but a growth factor that makes islets happy again. The tumor microenvironment is something that oncologists are dreading, because immune systems, cancers know how to avoid an immune attack. But those tricks from cancers are the ones that I want to teach to pancreatic islets. So I want to create that environment around the islets so that the beta cells will not be attractive to the immune system. So we do the complete opposite. Now, nearby in Seal Beach, there's a big company, almost worth $1 billion, called Dendrion, and they're making vaccines of immune cells that are loaded with cancer antigens so that it stimulates the immune system to destroy the cancer. We are doing the same, but not activating the immune system, but inactivating them. And the only difference, really, between making a cancer vaccine and making a diabetes vaccine is using vitamin D3 during the culture. I start smiling because, listen, this you can buy even at Ralph's or Vaughn's or wherever you do your shopping, right? This is a food supplement that we happen to know is in shortage with people with type 1 diabetes and with people that get severe COVID. So this is something that you can do just as a supplement, and we're treating immune cells with vitamin D3 to make them anti-inflammatory. So we are doing things completely differently. A quote from one of my favorite episodes of Monty Python. Now, I hope this is too wordy, I get that. So I have made a movie animation to show what this is about. And I cannot speak through this because then the voiceover disappears. So I hope it's working for you guys. But here is two of those strategies, namely the CAR T cell and the bionic that we're developing for cancer, for diabetes from cancer. So here it goes. Let's see whether I can get the movie going.
The story of type 1 diabetes is about a conflict between two cells in your body. The beta cell, a cell that produces insulin, which controls your blood sugar, and the T cell, a cell whose main role is to fight foreign invaders in your body, like viruses and cancer. Type 1 diabetes starts with a beta cell in distress, a cell sending signals that something is wrong, and an overly aggressive T cell attacking it. The problem is, T cells are only supposed to target foreign invaders, not self cells like beta cells. At City of Hope, scientists are testing advanced technology to stop that T cell attack and potentially cure type 1 diabetes. One, called CAR T cell therapy, is a way of using genetically modified cells to target overly aggressive T cells and stop them from killing beta cells. Another promising therapy is triggered by substances released during the T cell attack on beta cells. That release is a signal for a medication to be dropped right at the site of attack and for a T cell's action to be blocked. It's like a rescue mission for a beta cell. Another promising path City of Hope scientists are pursuing to move closer to a cure for type 1 diabetes.
Well, I hope you could hear it, but it is two different strategies. One is targeting the inflammation and the other one with cells, with immune cells. And the other one is an antibody with a backpack with a growth factor that makes islets happy again. And the beauty is that each of these strategies you can use at a different stage in the disease. So if you here look at what I call the disease radar, green meaning good and red being bad, so the rate of inflammation in your islets, we're born with a lot of beta cells, and at some stage their functioning number is declining. So during the medical emergency of the diagnosis, we can use the CAR cells, but before and after we can use those new antibodies or our vaccine. So we can now actually, we're building therapies that we can use in different stages of the disease to reach more patients and reach also people that have been ignored until today, namely those that already have the disease, because there is something to offer to those patients. Now, Joanne, my host of today, and your host, asked me to talk about two therapies in particular. And I chose the vaccine and this one. This is poop transplantation, a brand new trial that we just published this month, March 2021. And what we do is we transplant the intestinal flora, the microbiome that we all carry, back into patients after we clean it up in between. So we take some stool, we put it in a blender, and then we infuse it through a tube straight in the small intestine, after we had cleaned the whole gut. And that way we basically refresh, excusez le mot, the intestinal flora. So with that strategy, we have accomplished a spectacular result. We stop disease progression with your own flora, because we took donor poop, which is blue, or your own poop, which is in red. And as you see, normally when you're diagnosed with type 1 diabetes, these are people with newly diagnosed type 1 diabetes. Normally, I need to get my pointer back. There is a decline in function every year of about 20%. Now, when we take autologous stool, that is already slightly less, or blue. The donor stool, it is a little bit less. But with your own stool, 1 year later, you make the same or maybe even more insulin than you did at diagnosis. So your honeymoon is extended. And this is also shown by different ways, a mixed meal tolerance test, HbA1c, 6.1. Well, I'm not sure what you're used to, but it's pretty darn good to have an HbA1c of 6.1. I mean, that means that you will not get complications. That means that you are virtually having perfect glycemic control. So that is what this stool transplantation is doing. Now, how does it work? Well, we're still figuring this out, and this is a lot of work, as you can imagine. But we, for instance, are looking at the composition of the flora, different bacteria that we have in the gut. And you see that the ones that were so successful had a lot of this before the therapy and very little after, whereas the group that had less effect had the other way around. So if you look at that, you can already identify a couple of bacteria. So of course, the dream is that in the end of the day, we're not going to have to transplant stools, but we can just pick the probiotics that we normally could have carried and put them in a pill and put them back, like a Yakult or wherever yogurt drinks you prefer, put it back into your intestine and have that repopulate your intestine. So this is one way of looking at it. But it's a little bit more complicated than that, because I, as an immunologist, I looked at their immune profiles before we treated them. And I could actually predict for each and every remitting patient whether they would remit, and for relapsing patients whether they would relapse. Because this is just splitting those two on basis of their immune profiles. And you can see the one group which already has a favorable immune signature makes the same or more insulin after a year after than the group that had an unfavorable one. So we again are moving in the direction of personalized medicine. But it's a complicated story. So your microbiome, the bacteria in your gut, are communicating with your immunome, your immune system, to determine health or disease. And this is going way beyond diabetes. We know from the Cancer Center at City of Hope that whether immunotherapy or even chemotherapy works depends on your microbiome. And that's one thing we can change, right? We can, manipulate a little bit. You can also do it with diet, but you can also do it more substantially by poop transplantation. So this is one example how we are moving forward in stopping the disease and learning along the way how and whom we could treat with this type of therapy. I'm sure it raises lots of questions, and I'm happy to try to answer those in a minute. So the final therapy that I'm going to discuss is the vaccination. Now, in the last decades, far fewer trials were done that attempted to selectively educate the immune system. It's like with allergies. If you know your allergen, you can desensitize against that specific allergen. So if you think you know what the target is that your immune system is responding to in the insulin-producing cells in the islets of Langerhans, you can design a vaccine and try to change that. And that's exactly what these different trials are trying to do. Now, I developed my own trial, which is called DSense, because I'm using DCs, dendritic cells. We're desensitizing, and I thought it was a pretty decent trial as well. And it is a strategy where we take immune cells from the patient, we revamp them a little bit in the lab with vitamin D3, and then we add our vaccine to inject them back into patients. Now, this was a phase 1 trial, checking whether it was safe and feasible to do this. So basically, we take some blood from the patient, and with magnetic beads, we isolate the precursor cells that we want to culture in the lab to become the new directors of the immune orchestra, and we're manipulating those cells by adding vitamin D3. That is the difference with the cancer therapy, where we leave the vitamin out. And then after 6 days, we can freeze them, and we make an appointment with the patient to be injected. And 2 days before the patient will show, we thaw those cells from the liquid nitrogen, and we add our vaccine, which is a little bit of the proinsulin molecule, the hormone that we need to control our blood sugar, and then we inject it back into patients. And we do that with another new strategy. We don't do that in the blood, we do that just above the pancreas. So here is our competitor, the closed loop with the sensor and the pump, but just above the pancreas, we use microneedles, and I always add to this, these needles are so small that even men can tolerate them, so they're microneedles. And those are the cells where we deliver those immune cells, the vaccine, under the skin, intradermally. So those cells immediately swim to the pancreas and the pancreas draining lymph nodes, and that's where they do their business. That is one of those examples how you can make a therapy targeted. Don't treat the whole body. The problem is only in the pancreas. Just treat the pancreas. Now, here's one way of doing that. And here is the result. This is just published last summer in a journal called The Lancet, where you can see that where we inject those cells. Well, this was the placebo. Just injecting, you get a little blister, which disappears 1 hour later, and then 2 days later, you don't see anything. But if instead of salty water, you inject our vaccine, you see the same blister, but also a little bit of redness around it. And that means something is happening. Very, very exciting. And an hour later, you can still see something happening. But in the meantime, those cells are moving to the pancreas. And 2 days later, you don't see anything except where we injected the cells. And then we're going to boost, just like with COVID vaccinations, we do a prime and a boost. So 1 month later, we injected the same vaccine, and we were a little nervous because things could have gone horribly wrong, theoretically, but they didn't. We see exactly the same. Some redness, the cells disappear, and the redness is gone in 2 days. So this is how tolerable it is, and there were basically no side effects. But when we then studied the blood, and this is not published yet, and we looked at the immune responses, we could see that the immune response to a growth factor was completely unaffected, which is just what you want. You want the immune system to be prepared for cancers and for infection. A response to tetanus toxoid was also completely unaffected. So your immune memory was not harmed. But the immune response against pancreatic islet antigen was completely gone. So we actually managed to completely stop the autoimmune response to the islets. So we are actually stopping the disease process. I couldn't believe it. So we, a couple of years later, invited those patients back in the lab to see whether that was still gone, the autoimmune response. And here you can see this was before therapy. It goes up a little bit because you need to stimulate the immune system to learn it how to do it right. That's why you shouldn't suppress. It went down and it stays down. So I called the pediatrician, a friend of mine, Henk-Jan, to tell him the wonderful news that these patients were completely tolerant, had no autoimmune response to proinsulin. And he said, well, if you think that's interesting, you may want to know that they're all-time low in their HbA1c. So their HbA1c was 6.5 or lower, and getting better in time. So even though these were patients that had disease for over a decade, between 10 to 15 years, 12 years on average, we still saw this really strange impact on their glycemic control. And we had told those patients, don't expect anything because we might be too late. And here you see, you might not be too late. So this is really begging for a new trial. So where have we come with the Wanek Family Project? It was a very ambitious 6-year program. What have we been able to do so far to serve patients? Well, so far we have served 84 patients in different ways. For some of these, we stopped the disease process or we slowed it down. For example, with our inverse vaccine that I showed, or with this antibody, or with poop transplantations. In some patients, we actually established a complete remission. Now, this is the holy grail. This is what we call a cure if you don't need to inject insulin anymore. So there is a couple of ways to do that as well. And in the end of the day, we also happen to discover that if you take, by chance, less gluten in your diet as a pregnant mother, you can actually prevent diabetes in about 50% of the cases compared to mothers that take a lot of gluten. And when you do the numbers, we tested this, trust me, in 100,000 pregnant women, looking into their 20-year-old diaries. So those children had 20 years time to develop the disease. So we were very accurate. You can only do these studies in Scandinavia, where people are diligent enough to not only write down what they eat, we also keep those records. But that's why we discovered, and that basically in numbers means that we prevented diabetes in 29% of the cases unknowingly. So yes, we can prevent diabetes, and yes, we can stop it, and we might even be able to reverse it. So it's really getting exciting these days. Now, what does a cure look like? This is islet transplantation, and it already shows this is the blood glucose variation, which is spectacularly different. This is work of my colleague Fuad Kandil. So these are patients that have severe hypos and super frequent hyperglycemias. Those are candidates for islet transplantation. There is fewer and fewer of those patients thanks to the improved technologies to deliver insulin. But once you transplant, look at this. Completely normalized blood glucose. No hypos. The blue triangles here are hypos. They're gone. And when you look at the insulin dose in red, there is no insulin needed anymore. And their HbA1c goes from 7 to 5.1. So this is what a cure looks like in islet transplantation. But the problem is we need to have donors, and we need to suppress the immune system to avoid rejection, because the islets come from different donors. So that's why there's only such a very, very small group of patients that can benefit from this. But here's another thing that we developed during the Wanek Family Project. And basically what we did is we repurposed this particular drug down there called fenofibrate, which is a drug that normally is prescribed for people that have a high cholesterol to lower the bad cholesterol and increase the good cholesterol. And we discovered that the same drug actually is also blocking an enzyme that makes beta cells unhappy. So we treated this 18-year-old girl 2.5 years ago. She was just diagnosed with diabetes, and her father, who was the general practitioner, asked me, is there anything I could try? And we just had discovered this drug together with my friend Carsten Bouchard as a candidate to make islets happy again. And so this is the first beta cell therapy, if you wish. And you can see that she's now almost 3 years later, her blood glucose is completely normal, and only once she injected, 1 or 2 units of insulin. That's it. So she has, let's say, an extended honeymoon of almost 3 years now. So she could have finished college in the meantime. That's very meaningful. So I'm just showing this to remind us what a clinical benefit may look like. And sometimes it's stopping the disease or preventing hypos, and sometimes it's making people insulin independent. So it can happen, but only thanks to an enormous teamwork. And from the data that I showed from my own studies, these are all the people that have been involved in these studies to show that this is teamwork and it's global. It's people from Europe, people from Southern California, as well as everywhere in between and beyond. So that is the new exciting time of team science. And with that, I stop talking, and I would love to answer any questions that I may have provoked in this group. Thanks very much for your kind attention.
Oh my goodness. Oh my goodness. Lots of buzz going on. First of all, thank you very much. We don't often hear people legitimately talking about a cure. And those of us who've lived a long time, I was told there would be a cure in 2 years in 1965.
Okay.
So there are several of us who heard that. But we see what you're doing, we're understanding it. So let me start at the top of the questions and try to work my way down. Let's talk about fecal transplant. As you know, I actually went through that not for diabetes, and it was very remarkable. But in these larger programs, and if it becomes something that is doable, where does the poop come from?
Well, the beauty is, if I may use that word in this context, the best effect was with people's own poop. And I think that was a chance finding, because we actually used that arm of the trial as a control. We were expecting the donor poop to do better, and it did slightly worse. But we were kind of lucky that it also turned out that those patients that had a more favorable immune response happened to be in the autologous, in the own poop arm. So we still need to learn, but the fact that your own microbiome might already suffice is, of course, making it a little more attractive or less unattractive to try, right? But and with donor stool, you always have to be careful that there is not a pathogen in there, or. But I want people to understand that we're not just weirdos doing this, and this is the standard clinical practice. If people have very chronic bacterial infections with pathogens that cannot be treated in any other way, then this is the last resort, and it works. But strangely, my friend Max in Amsterdam, some of those patients happen to have metabolic syndrome or type 2 diabetes, and they went into remission. And he said, hey, you work on type 1, don't you want to try it? And I just thought, there's a lot of talk about this. I just don't believe it. So this is the easiest way to find out. And if it doesn't work, I never want to hear about this, but it works. So now we have to find out how it works and why and in whom. But it does make sense. I mean, your intestines is your largest immune organ. Any moment in time, about 90% of your immune system is happening in the gut, which I understand, because there is a 100-fold excess of bacteria than we have cells in our body. So there's a lot of action going on there. But it is extremely effective in keeping us healthy, right? So that's one way of addressing this. And I think this is food for thought.
I've been writing for years on my blog about the gut biome, and I've seen the research that says within a year of diagnosis of diabetes, your gut microbiome changes. If you would be using our own poop, excuse me, but I sound like my grandson. If you'd be using our own poop, would we modify a diet before to try to make the gut healthier?
Well, that's a great question, because I prefer not to have to do this. I mentioned gluten, right? Yes. Gluten is one of those food components. It's not even a nutrient. It's there to make bread fluffy and stuff like that. Make the pizzas taste well and the beer. But the gluten is a relatively recent nutrient in diet of primates, only the last 20,000-30,000 years. So our intestines hate dealing with it. And the point is, the bacteria that you need to process gluten are pushing out bacteria that make essential nutrients. So even by reducing gluten intake, you can already kind of manipulate your biome. Now the problem is, I can say it, but it's very hard to prove, because I cannot tell you, you're placebo, please eat gluten, right? Because everybody will change to gluten low. And I'm saying low because life is hard enough as it is for a person with diabetes. I don't want to change your lifestyle altogether, but just take it easy. We don't need that much gluten. And I know otherwise perfectly healthy people, when we grow a little older and we feel a little uncomfortable, people start to take less gluten and feel better. So it is something that you might want to do anyway. But here is one way, and our proof in those pregnant women was bizarre, right? 50% of the cases, right? Half of the people with diabetes. If that's true, I mean, and even if every patient matters, if even, our children or grandchildren, we can tell their mothers, in addition to folic acid and vitamin D during pregnancy, take it easy on the gluten, right? We also stay away from uncooked milk, cheeses, and stuff like that. So if that works and it's only during pregnancy, I mean, what a spectacular breakthrough that would be.
You just mentioned cheeses. How does that play into it?
Well, that was just coincidental. There is so much to be learned, and I'm just a simple immunologist. But I just think that, we know breastfeeding, for example, is a protective, slightly protective. It's moderate. These are subtle differences. It's not usually not 50%, but a few percent more or less chance to get diabetes. But that's significant. Anything we can do to prevent it will help. Well, and breast milk is one of those things that you can that give your child a good start. Now, one of the things I'm worried with is the how quickly we take antibiotics. And very often I hear of parents of young children that develop diabetes that their child had to be put on the most horrible antibiotics for the first 1 or 2 years in their lives. That really worries me, because those bacteria are such an important component of our body. They are our allies. We cannot do without them. So I'm always worried about when I hear that. And when I was young, which is a while ago, I mean, the first time that children would get their first course of antibiotic was when they were mid-teenagers. Now it is within 9 months that babies get their first antibiotic. I think we should maybe reconsider that, and maybe be a little bit more, have a little bit more confidence in the immune system, because it may take a little longer. But hey, people with diabetes have the best immune system in the world, so give it a break.
So I have one more question on the fecal transplant, and then I'll move on to vaccine. Would you see that would be something that's a one-time, or 3 days in a row, or once a month, or do you have any sense of how often?
Which one was it exactly? Which strategy?
The fecal transplant.
We did that 3 times with 2 months apart. So it takes a little time to have, this is also your biome is very personal, but it also takes a bit of time to kick it around a little bit. So we did it 3 times, but that's only because that is the standard practice. We probably can do better there as well. But it took a while to have a lasting change in composition of the gut. I'm so sorry just before dinner to bring this up, but anyway, it's the way it is.
We have people on the East Coast, they've already had their dinner. A question about the vaccine. You were showing the responsiveness to the vaccine over some time, and you mentioned that the vaccine is then moving into the pancreas. How do you know that? We
only know this from similar studies that were done in cancer, or by friends of us in Pittsburgh that tried to do it with engineered immune cells. And they did labeling studies. And I dread to say in non-human primates. So I try to not do that, but sometimes I can just learn from other people doing experiments that you don't want to happen. But they showed that those cells ended up in the pancreas and the pancreas draining lymph nodes. I will do studies in humans in the next phase, where we will label those cells and we will track that label to see whether that's really right. But in the end of the day, if it stops disease progression, do you really care?
No, not at all.
So I mean, I'm always curious that the nature of a medical scientist. But I don't want to just, inject labels in patients if there is no real need for it. You see what I mean? So maybe I have to suppress my curiosity once in a while.
So on the vaccine, when you were showing the HbA1c numbers, were those without any extra insulin?
Yeah.
Oh my goodness.
Yeah.
Okay.
And the hypos went down too.
Wow.
And these are patients where I said, well, you are my hero because you altruistically volunteer in a trial where you have no benefit. We just needed to show it's safe. And lo and behold, actually something. It's small signs and not in everybody. Don't get super excited, but it fits with the fact that I believe that there is things we can offer to people with established disease. And I wanna get a chance to be able to show it, because nowadays trials are strictly restricted to diagnosis and the few weeks after. That is probably wrong. We need to have everybody get access to some sort of medication. So here is one way of looking at it, but it's a surprise finding. And you know what? Whenever things come as a surprise, I think they're more credible. Right? If I didn't expect it and it's there, I mean, you cannot blame me for being, it is a result. And remember, that's why I told the story that I called my friend, say, hey, they're still immune tolerant. And he said, but hey, you may want to know that they're all-time low after more than a decade in their HbA1c. And I asked him, why didn't you tell me? And he said, you didn't ask. You see, so it just reminds me that, always keep asking. But the fact that this is serendipitous, it was unpredicted, and to me, I believe it. I hope you do too. And if you don't, well, I respect that.
Though I think we're all just listening as intently as we can. When you give a vaccine to temper the immune response, is there a concern that you're turning off some immune response to another disease or another process?
There is always the risk, but that risk is so much smaller compared to the drugs that we are currently testing, which are big hammers. There are antibodies that actually take out all the immune cells. Are you kidding me? That's what we're testing, right?
Yeah.
So, or chemotherapy. Some of the trials in type 1 diabetes are classic chemotherapy. They stop cell growth, right? That doesn't sound good. I mean, I want some of my cells to grow. Trust me. I mean, I need some more on my skull. So those are things that I don't want to do. And I honestly believe that, and this is that in particular, people with diabetes have this wonderful immune system, right? Normally, people need, for some vaccines like papillomavirus against cervix carcinoma, you need to prime, boost. But people with diabetes sometimes only need one shot because their immune system just gets it, okay, I'll get it. So I think we should honor that and respect the immune system and don't call it a mistake.
I'm going to jump around here. So lots of questions coming out now. For the T1 antibodies, for the cluster, Nina, I'm not sure I'm understanding your question. Is it possible that beta cells are working, but autoantibodies are destroying the produced insulin?
Yeah, so here is another thing where I made quite a few enemies amongst my peers. Those antibodies are extremely unlikely to play a role in the disease process. I very briefly called them the smoke, but not the fire. The point is the targets of those antibodies are in the beta cell. Those antibodies can never go there. So they probably are a consequence of the disease rather than a cause. So they are very good at measuring whether something bad is happening as a predictor. But all the trials until today that were targeting antibodies or the B cells making them, they had very little effect. So I'm just looking at the data, right? I know I have an opinion, but I think that antibodies are not to worry about. I think so the real question is, why are those beta cells hibernating? Why are they hiding, right? I only have an immunosophical interpretation. I think that if there is an inflammation going on in cells that make vital hormones, our body is so smart to just say, you know what? Let's not do that. Let's not be lemmings jumping off the cliff. Let's just hold back and wait till spring or whatever. You know what? That's what I believe. So please allow me to say something, because it just shows how I try to understand what my stakeholders need. The question is always, what does it mean to me right now, right? And I already answer I already asked your questions and try to answer them. So taking care of your blood glucose is the best thing that you could possibly do, because a good glycemic control protects your beta cells. So rather than when you tell a teenager, well, it prevents complications, they don't care about that because those complications are far away. But if you tell them, listen, you have beta cells and they may come to rescue those, but then you should try to keep your blood glucose right, that's such a much better motivation, isn't it? So I think what you guys have been doing painstakingly for many, many years is exactly what your beta cells were craving. Give them a break and give me some time to vet those intervention strategies and see which ones are best suited for you in terms of personalized therapy.
Okay, I'm going to jump back because the questions are all over the place. Is there a hypothesis about why autotransplantation of fecal matter works better?
Well, I think it was a chance finding that it was better than donor poop. Yeah, I can use poop in America, can I? Or is it a really bad
sure,
word?
bring it on.
No, I mean, I don't use the S word, but I try to be considerate of my new environment here as an alien, a green card holder. But the point is, I think it was a chance finding. Actually, that whole trial was just luck upon luck upon luck, because we had calculated that we needed close to 40 patients to get a significant difference. And normally with every trial, we have an independent data safety board that is looking at, for me, it was blinded, but they can look to see whether something bad is happening. And they stopped the trial halfway because it was so significantly successful that it was unethical to move on. Mm-hmm. And you can imagine that it wasn't easy to find volunteers for this trial. So at that time, we sat back and said, okay, let's study this. And then it turns, I believe that we were just lucky that the background of the donors that got the autologous stool, your own stool, was more favorable than that of the other group. But I need to prove that, and we will. We are now taking that to the next level. But I think it's a chance finding. But I may be wrong. Anyway, you saw the data; they're now published, so you can have a look if you care.
So along those lines, if your own microbiome works, then why doesn't it work without needing?
Why didn't work in the first place? I honestly believe it is a matter of balance, rebalancing it. Like with the immune system, with our vaccine. I mean, mind you, with all those other trials that people are doing, you see significant impact on your immune system, right? Because they are big hammer interventions. We hardly saw anything, which I think is a good sign, because I don't want to change your immune system, but I want to rebalance it. With allergy, you only want to affect the response to the allergen, not the response to COVID or cancer. So I think that's what we have been doing, just subtle differences. And I think the whole principle of stool transplant could be maybe one or two probiotics that could make the difference, but we just don't know which is why we did everything. But it's a matter of finding the right balance again.
So interesting. We have a question. My son has been on trimethoprim from birth. DT, I don't know what DT is, one kidney. He's it's a 1 year now on trimethoprim. So would he benefit preventatively from fecal transplant?
Yeah. Well, with children, I'm always a little bit more careful, but we know from very young children how important the biome is. For example, cesarean sections, they increase your risk for diabetes, because normally when you have the natural delivery, automatically you get some of your mother's biome with that, and that gives you a kickstart with a healthy biome. And so very early in life, your biome is already mattering. So I'm just a little reluctant to treat young infants, but it could, you know. I'm just saying. But so could diet. I remember a desperate mother after one of my lectures in Europe a couple of years ago, who was in tears because her child was uncontrollable. Her blood sugar went all over, and she checked her all night long. It was terrible. She said, "Can you, is there anything you can do?" And I said, "Listen, I give you the answer as a father, not as a doctor. Try to give a little less gluten, right? Just because, I mean, I cannot prove how it works as a scientist, but I can at least try to give people a chance to get their kids in order." And 3 months later, I got an email. It is in my mailbox, and she said she doesn't need insulin anymore.
Wow.
This is one case, but and I said, "What do I do?" Well, I said, you know, insulin saves lives, so don't keep it away from the sake of keeping it away, but don't give it if it's not needed, right? But it shows a couple of things. It shows that kid apparently still had enough beta cells to make her own insulin, right? You see?
Yep.
That is one of those examples where you can see that. And second, it shows that you can get them back in action too. And third, it shows that even moderate lifestyle interventions can come a long way. But I told you in my talk how diverse people are. So that this is no guarantee. But if you, I mean, I also said it because it's pretty safe to say, right? I mean, the gluten is not as essential, so it's safe to say you don't die from not getting it. But I mean, here is one of those cases. And then I did a trial with my friend in Denmark, and he has a 12-year-old that is out of insulin for over 2 years now with the gluten-free diet. The problem again is I cannot do a proper trial, because if I tell you you're the placebo, you'll say, yeah, sure. And by the way, I'll also take vitamin D, and you know, I mean, and you should, of course you should. I'm not going to tell you what to eat or give your children, but in any case, I'm just trying to say, listen, guys, there is light at the end of the tunnel, and we're learning, and there's so much to be learned. This is stuff from the last 3 years. I mean, it's crazy.
So 2 questions. One, do you abstain from gluten? I have to ask.
No.
Okay.
No, I have this guilty pleasure that I like microbreweries and stuff like that. So, and no, the odd pizza, you know, and I love pasta. And I know that when you go to the supermarket, you know, the alley that has low gluten is phenomenal, right?
Mhm.
It's just that, but sometimes I choose a cauliflower pizza. And I actually like that. So, but no, I don't. But you know.
So the question is, people with gluten intolerance or celiac disease, are they more likely to be cured?
So here's a very interesting story. I'm not sure we're running out of time, but this is an experiment of nature. You may know that the risk for gluten is completely identical with the risk for diabetes. And the epidemiology, the north-south gradient in Europe and Sardinia being a hotspot, that is the same for diabetes and celiac disease. And also, you get it around the same age as an infant in many cases. So if that is true, then there is always a group of diabetes patients that has both celiac disease and diabetes, right? So statistically, 50% first gets diabetes and then is diagnosed with celiac disease, and 50% the other way around. Are you with me?
Mhm.
Right? So that, but what happens is 95% of the cases, diabetes is first and then celiac disease develops.
Yeah.
And I was trying to understand that. And then I realized what happens when you are diagnosed with celiac disease. You go on a diet. And when you go on the diet, you prevent type 1 diabetes. How about that? So it could be that just because of this dietary intervention, the group of patients that would then subsequently develop type 1 diabetes actually managed to escape. And I'm just looking at the data, and this is speculation, don't get me wrong, but I'm just, the plot is thickening, right? That gluten during pregnancy is, the fact that the bacteria that gluten pushes out makes essential nutrients like gamma butyrate, which we need as a vital nutrient. I mean, it kind of makes sense. It just is difficult to grasp.
So back to the concept that we have beta cells. A question, after 45 years post-diagnosis, is there any chance that my beta cells can ever be viable to any degree?
So that is the most important question I have, we all have. I have been involved in a study with my friends in Exeter at the English Riviera. Sorry, I just cannot combine Riviera and England in the same sentence. But anyway, it's on the South Coast. And they discovered that, strangely, there is a 7-year itch in the decline in beta cell function. So it looks pretty much like what you have after 7 years is what you keep the rest of your life. And that is function. That is just showing that there is a kind of turnaround point, an inflection point where things are back in control. So what if we can make that inflection point sooner with therapy? That would already be great. But that is just the function without any intervention. I would not be surprised that we can get hibernating beta cells into action. And if we can't, there is a whole other group of colleagues of mine that are making stem cells from patients, from yourselves, and turn them into beta cells, right? So there is always the possibility that we get new sources of beta cells. Now, this has been another thing that you have heard for about 3 decades, but that too is getting closer than you think. So, but that would only help if we can close the tap, right, before we start mopping. So we need to first stop the immune response and make beta cells happy again, and then see what else we need in some patients, maybe not in others, to also get sufficient amounts of insulin. But I've been told by many patients, they don't care that they need to inject insulin, whether they inject 5 or 20 units. They want to have a good quality of life. They don't want to have this full-time burden and concern that you take too much or too little. And even a few functional beta cells can make that difference. So I try also to tell my stakeholders not to put the bar too high. Of course, I hear you, and trust me, I won't stop until we can accomplish insulin independence, but stopping the loss in function is already very valuable, and getting beta cells back in action is valuable. So, I mean, right? I mean, let's not kid ourselves. We need to count our blessings. Let's put it that way.
So there are a bunch of questions that are more global. So I'll just throw a bunch of them at you. One is, what type of cure would you expect to come to market first? And do you anticipate any pushback from companies that would go bankrupt if you cure type 1?
Now I'll start with the second one. Whenever I started working on this 30 years ago, I just came out of kindergarten, for the record. So do your math. But so are they worried? Of course they're not. I mean, everybody cares about patients, and if we find growth factors that make beta cells happy again, they prefer to sell growth factors over insulin. Trust me, right? So don't worry. I mean, I've never, ever experienced any conspiracy against curing a bad disease. That doesn't happen. But having said that, your first question was what comes in the clinic first?
Yeah.
I mean, I'm just so blessed to be able to work on 4 or 5 different, completely different strategies for different patients at the same time. Nowhere in this country there is any clinic that can offer more than one therapy, right? We, at this time, at City of Hope, can only recruit patients for the vaccination trial. So if you're in Southern California and you have less than 5 years of disease, write me an email or go to the City of Hope website and find, because we need you for this trial, possibly. I mean, we have very stringent inclusion criteria. A little problem that we have in diabetes is the fact that we have insulin, right? So the FDA is pretty tough on us not to go crazy with all kinds of things. So we have to make smaller steps, maybe. If I would work on COVID, my drug will be in the clinic immediately. And by the way, the one antibody that we are developing for type 1 diabetes with the backpack and the growth factor has received emergency approval to be tested, given to patients with COVID in the clinic. So sometimes I can accelerate a product by testing it in another disease. And that's why I'm pretty excited being at City of Hope, because we even have a pill against complications. Now, if you get chemotherapy, you also can get neuropathy, pain. So it's more easy to convince the FDA that we should offer this to patients getting chemotherapy. And we see it much more quickly than having to wait 20 years in diabetes. So we try to choose other diseases sometimes to work more quickly and at least show it's safe. And even if it doesn't work in one disease, but it's safe, I still want to test it in diabetes. In fact, in the old days, we were not allowed to test drugs in children, but now that we know that diabetes in children is different from diabetes type 1 in adults, even if it doesn't work in adults, but it's safe, we can more quickly go to children and try it in children. So the FDA, we are educating each other, and the FDA sees that, you know, the disease is diverse. Let's not keep young children from having a potential benefit, and they are more worried about off-label use. So if we only test it in adults and never tested children, they prefer that we also test children. So this is a kind of a blessing in disguise, that we can at least get the chance to also test some of the drugs in children. But I showed you one slide with some therapies that never work in adults and only work in some children, and the other way around. So we really have to open up our minds. And by the way, 50% of all new type 1 diabetes is diagnosed in 30-year-old patients and older, right? It's not a children's disease alone. It is only we don't recognize, or we call it stupid things like LADA or type 2 diabetes, but that's type 1 diabetes. So we need to find drugs for everybody at any age. And the drugs that will be most helpful in an adult onset diabetes, type 1, may be different from type 1 diabetes drugs in very young children. Certainly in children, they must be a little bit safer, right? Because we don't want to harm kids or anybody for that matter.
2 more global questions, and then Cassidy has a question. So how do people get involved in trials? Are you doing anything outside of the area?
Well, and what is the area?
So, Southern California.
Yeah, so, you know, I want to be all-inclusive, except that if you do phase 1 trials, you need to have direct access to the patients. If new things occur, we need to know it quickly, and we need to be able to access the patient very quickly. So that's the reason why we need, some of those cells are cell therapies. Some of those therapies we inject cells, right? So you want to be close by. It's safe, but I want to be reassured that it's safe. So that's the reason why we take those drugs more locally. But the bionic, I think, which we can give to a much wider group of patients, for that we need phase 2 trials that probably require as many patients as we can, and those are off-the-shelf drugs, right? They're like, you don't have to put them in the -70 freezers. You can basically put them in the fridge. So for that, the probability that you can get access outside of Southern California is much greater. But we have to make, we first need to negotiate with the FDA what they prefer as a test group, and so all I can say right now is go to the website and see what's out there, and get on the mailing list, so you get newsletters and stuff like this. I'm as impatient as many of you. Trust me. I don't have diabetes, but I live it every minute of my life. Don't mind sacrificing a Sunday afternoon. I want this to happen before I retire, and I want to retire pretty quickly. So this is a win-win. I work as hard as I can, but I don't want to force things, because that would ruin it for all of us.
Well, thank you. I'll post the connection onto our Facebook group and also on the website. Interesting question. One question, and then Cassidy, if you can jump in. Is there something you wish scientists in type 1 diabetes would do differently or think about differently so we can get to a cure faster?
Yeah, that's a tricky one. Science has changed. Medical science has changed spectacularly, and the egos are retiring, and we get much more group science. So there is a lot less egocentric protection, and there is a lot more altruism there. A lot of it is I wouldn't have gone anywhere without working with all my friends in Florida, in Japan, in India, in wherever in the world. So that is already changing. But what is very, very difficult is to be told that you might be wrong, right? So if I tell people that work on antibodies, why don't you try T cells? It hurts, because we're all human beings. So the one thing I've learned as a very young kid is you can be stubborn, but you should keep listening and make up your own mind and check what's out there. The fact that I now believe diabetes is a beta cell disease is a bombshell. I mean, even before it got published, it already was cited by people like, what? And that is coming out this month, right? So it's really new insight, but it makes sense. That has a profound impact on many people's view of the disease. And, it's just difficult to teach an old dog new tricks. So, and I'm an old dog, so I get it, but listening is important, taking things at face value, and be able to adapt now. And that's, there's always enough people that are willing and able to do it. And the younger they are, the more willing they are, right? So it's okay. With time, people turn their heads and change hypotheses. But many dogmas turn out to be dead dogs. But that comes with a lot of pain and suffering from those that spend careers to work on it. So I have to learn to be a little bit more gentle, and other people may have to learn to listen to this gentle person.
We don't want you to be more gentle. We want you to do what you've been doing.
People call me a rebel with a cause, and I kind of think that that's something I'm a little proud of, although it's also a little bit awkward. but that's what I am. You know, I don't mind. I'm cutting to the chase. And you know, in the Netherlands, we are very frank and we say it immediately, and we think we're honest, and the rest of the world calls us blunt. So I need to be a little more considerate, but I have a sense of urgency like you have, and I want to get this disease. I mean, when people said 6 years, why 6 years? Well, I prefer 2 years, I said. You know, I mean, there's nothing wrong with being ambitious, but every day is too long. So, you know, that's why I'm sometimes a little bit rude and blunt. But anyway, it's for a good cause, so I hope you forgive me.
The comments going by are, that's great, we love it, don't stop. Yeah, bluntness is, well, we want that. We feel that urgency as well.
Yeah, I feel that too. I mean, I have no time to beat around the bush. And there's people's lives out there that we can improve, and it's pretty simple.
And
Is
also,
that-
like, take any rebel without a cause James Dean reference you can take.
I thought about
I mean, hey, I will like take the torch and just like take that directness to like hopefully end us tonight on a patient note. You made this mention, and that barcoded image of blood product, like green and red, was all over that presentation. What makes us have a signature? Like, what if Joanne or I have a good or a bad blood product signature for these therapies? What makes it good or bad?
Well, I try to not get into too much detail there, but it's a mixture of. So I basically we test in the blood the amount of immune cells that may be autoreactive, and this is incredibly difficult because it's less than 1 in a million, right? But I've spent the first 20 years of my life to develop those assays and to be able to accurately measure that. And most people were not patient enough to do it. But we have that now. So we can basically enumerate that, and then we take a little further. We see, okay, so is it one specific protein, or is it 4 of the beta cell, and the more, the worse the prognosis gets. But it also has a little bit to do with the genetic background. So if you have the full set of gene variants that may increase your risk, you tend to have a more severe immune reaction. You're probably also better protected against cancer, except for diabetes, it's bad news. So those are all things that interplay. So it's a combination with genetic risk scores and gene barcoding, but I try to avoid that people think of us like we are putting barcodes on people, right? It's more of a, more of a different shades of gray type of thing, that we want to find what shade of gray you have. And we found out that some are very useful for some therapies, and others probably would do better with other therapies. That's kind of the background of that.
You had that image, obviously, that you referred to just back in the Q&A of like time, based on time, like based on age, which of these therapies like works just for age.
Yeah.
Can we overlay that with the same concept of like immune signature blood products?
Well, that's a great question. Young children are more likely to be more of a red barcode. The elderly very often already have a sort of a green code, and maybe it's reflecting that they already have natural ways to regulate their immune response. That's why it took 50 years before they got diabetes, and others only need a few years. Mm-hmm. So there is all kinds of that is part of it. But I also showed one slide which I immediately realized was too complicated. But when we look in the pancreas of very young children versus little older children, and we see that the inflammation is different in terms of the cells that are there and so forth. That was a shock to me. That paper is less than a year old, by the way. So the fact, and we normally never get access to the pancreas because it would mean that the donor would have died. So thank God for that. But it just means that there is probably a lot more to be learned, but it helps us at least understand why some drugs work in young and others only in older patients. I try to more look at it from that perspective. And of course, I would like to be able to change that barcode, which I think the biome is doing, right? The biome and working hard on getting your blood sugars right might actually push you from an unfavorable to a more favorable barcode. So that will be fantastic, because then that's what we do in cancer. If people have a biome that is not favorable for immunotherapy to cancer, we give them a stool transplant, or we give them some probiotics to change it. And there's companies in San Diego and elsewhere that make a living out of finding which few bacteria could do the same thing, so we don't have to go through these rough measures and change the barcode, really. So it's not all written in stone. The immune system is very capable of adjusting and adopting. So that's something where I keep saying, don't suppress it, engage it. It's a very precious gift we have.
It's such a different way than we think about
it. So
it's such a different way than we think about it. It's not that it's our enemy.
No.
Yeah.
No. It's our best friend. And then we give it all these horrible drugs, right? Yeah. So no, that is the whole point. And you know what? I'm many patients walk out of some of my lectures and are so relieved that they're not a mutant, right? At medical school, I learned that it was an inherited disease. That's rubbish. That is completely wrong. Type 2 is more of an inherited disease than type 1 is. But type 1, those are the winners of the Middle Ages, those genes. They make us survive COVID and cancers. Come on. I don't accept that it destroys beta cells, don't get me wrong. But I mean, I think it was with good intentions, because we have good evidence now that the islets that are destroyed, the beta cells, were stressed beta cells. And the immune system just isn't able to distinguish between a cancer cell and a stressed beta cell. I think that is the problem. But at least it was sophisticated enough to see it was stressed, right? How special is that?
Well, I will leave you with two comments: that you are shining true hope and your attitude is wonderful. You've made people feel good tonight, and thank you for spending your time and sharing with us.
Anytime. I told you this is so, I mean, I wouldn't call it a hobby, because that would make it kinky, but it is my life's mission to do. And it has been incredibly rewarding, as you could have seen, right? I mean, and I'm always saying, one patient, if you are that patient, or you are the mother or father or child or partner of that patient, every patient matters. And that's why I'm so excited with those small steps that we make. Because everybody said, oh, it doesn't work. No, but there is a few where it works. You know, count your blessings and learn why. You know, it's such a different attitude. But that I also learned from cancer, right? In diabetes, we always want to be insulin independent. But in cancer, they used to say you're cured if the cancer is gone. Now they say, no, if it stops growing, champagne in the lobby, right? And if you cure 12% with melanoma, you are a rock star, right? Mm. And when we only have an effect in 20% of the patient with diabetes, we say, oh, it failed in 80%. Come on, give me a break. You know,
you've really made people, their minds are blown tonight. So for the ones that were looking for devices, they got a whole different perspective.
No, those devices are perfect, because the more rest you offer to your beta cells, the more time I get to get this to the clinic.
We're working on it. Thank you so much. I'm thrilled to have met you, and thank you for joining us.
Well, thank you for having me. And as I said, most of this, all of what I've said is real data. So just trust me. The worst thing I could ever do is raise false expectations. Trust me. But what I've been trying to do is show the real cases and what it looks like, so that you can see that I'm not trying to, make things bigger than they are. It is an exciting time, and already today, the future of people with diabetes is different than it has been. Yep. So let's count our blessings, and let's keep supporting each other to make that better for even more patients.
Thank you. I hope you have a wonderful and exciting week.
I do too.
Thank
But I wish